Here's lesson 6, day 1 on vectors, and the learning targets are below. You can pause and read them. All right, this first slide, I would just say pause and read it in regards to what we're going to be learning about in this first lesson. All right, what I'd like you to focus on in this slide is our week is going to be spent on introducing what is a vector. So a vector has two important pieces to it. It has the magnitude, which is your distance, and then the direction in which that vector goes. Okay, so here's an example. You're driving due north at 50 miles per hour. The magnitude is the speed, 50 miles per hour, and the direction is the motion in which you go, which is due north. Some quantities can be completely described by giving only their magnitudes. For example, temperature of a lecture room that is just left of 75 degrees. So what we're going to be doing is we're going to work on the next slide where we identify what is a vector. A vector starts from a segment going from P to Q. It shows you the direction. The P is your initial point, and Q is called the terminal point, and we denote it by that line segment notation. The magnitude, which I talked about in the previous slide, is the length of a vector. The notation we use for magnitude has the double vertical bars, and what that represents, it's the distance from point P to point Q. All right. Geometrically, a vector is directed line segment. Vectors are often denoted by bold-faced letters such as V. So a vector can also be written like that. So if a vector V has the same magnitude and direction, then they're considered equal. So here's a graphical image of a vector. Starts at point P, and then it heads in the direction of Q. Remember, the P is your initial point, and Q is your terminal point. In this figure, they show different relationships between two vectors. So now we're adding another vector in, vector V, and then vector W. So the vectors in these have the same magnitude and same direction in 6.49a. So notice this vector V is the same length, same magnitude as vector W, and it's going in the same direction, meaning they have the same slope. So these are considered equal. If we go to example B, here's example B in this figure. These might have the same magnitude or length, but their directions are different slopes. All right, example C. Vectors V and W have the same length, but they're going in opposite directions. This is heading south, and this one's heading north, so they're not considered the same direction. All right, and then the last one, D, the vectors V and W have the same direction, so they're both heading northeast, but vector V is smaller than vector W. They're different lengths, different magnitudes. All right, so we're going to do this first example, show that these two vectors are equal. So we have figure 6.50 to show that these two vectors U and V are W, or U and Z are V are W. All right. All right, so here is our first vector. And then here's our second vector. And we want to show that these are the same length or magnitude. So in order for us to find that, we're going to use the distance formula. So to do that, the distance formula is taking your x lengths and subtracting them and then squaring them, plus your y lengths, subtracting them and then squaring them. That's your distance formula. So I'm going to start off with our first vector. I'm going to call this vector b, colored in green, and we want to find the length of it. So vector b, to find the magnitude, we're going to use that absolute value, looks like an absolute, that's a double bar, equals the square root, and now we substitute in, this would be our x sub 1 and y sub 1. This would be our x sub 2 and y sub 2, our 2 points, initial point and terminal point. So we're going to get 3 minus 0 squared plus 6 minus 0 squared. Simplify it. 3 squared plus 6 squared, which is the square root of 9 plus 36, which is the square root of 45. So this length right here in the green is the square root of 45. All right, now I want to find the length of vector u. So this vector in the red. I'll do the same distance formula. Notation for magnitude or length is the double vertical bars. Substitute in. We're going to let this be x sub 1 and y sub 1. And then this be x sub 2 and y sub 2. So 0 minus negative 3 all squared plus 3 minus negative 3 squared. Simplify it. 0 minus negative 3 is a positive 3 squared, plus 3 minus minus 3 is a 6 squared. Square root of 9 and 36 is a square root of 45. So this distance here is also 45. So we've now showed that these two are the same length. The other thing we have to show for these to be equal is that they have the same slope, the same direction. I'm going to erase that. So we're looking for the slopes of both of these lines. So we're looking for the rise over the run, the rise and run of those. So we'll find the slopes next. All right, I extended the page. We're continuing on where we want to find now the slopes of the two vectors. So let's start off with vector u. So to find the slope of vector u, you're going to use your slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now we substitute in. So 3 minus negative 3 over 0 minus negative 3. When we simplify that, we get positive 6 over 3, which is 2. Now let's find the slope of vector v. Using our same formula, y sub 2 minus y sub 1, the change of y over the change of x. 6 minus 0, 3 minus 0. Simplify it, 6 divided by 3 is 2. So in order for us to show that these two vectors are equal, vector u equals vector v, we need to show they have the same length, magnitude, and the same direction, their slope. So we're looking for the magnitude and the slope. So these two vectors are the same. They're just in different places on our coordinate plane.